Today, we're going to demystify one of the most useful tools you can have in your kit, the digital multimeter. Seriously, this thing is your secret weapon for understanding the invisible world of electricity, and I'm about to show you just how easy it is to use.
Yeah, I get it. You'll look at this thing, all the symbols, the numbers, the ports, and it feels like you need an engineering degree just to figure out how to turn it on. Trust me, you are not alone in feeling that way.
That's probably the #1 reason people just leave these in the box. But here's the good news. That feeling of confusion, it's about to disappear.
And I mean that. That's a promise. By the time we're done here, you'll be able to confidently grab this tool and start solving some of those real-world electrical puzzles. So let's dive right in.
Okay, first things first, let's break this tool down. You can forget all the noise and complexity for a second, because there are really only 3 parts you need to focus on to get started.
It really just boils down to this. You've got the display, right? That's where the answers pop up. Then you have the big dial in the middle. That's how you ask the questions. And finally, the ports at the bottom, which is just where you plug in your probes to actually touch the circuit. That's it. Display, dial, and ports. Simple. Now about that dial, you're going to see a few key symbols. Think of this as your little cheat sheet. The V with that wavy line, that's for AC voltage, the stuff from your wall sockets. The V with the straight line is for DC voltage, like from batteries. That Greek letter omega, that's for resistance. A is for amps, or current, and that little symbol that looks kind of like sound waves, that's for continuity. A super useful function we'll get to in just a minute.
Quick heads up, you'll find 2 main types of these out there, auto-ranging and manual. Auto-ranging is, well, easier. You just pick what you want to measure, say DC volts, and it figures out the rest. With a manual meter, you also have to pick the range you expect. But hey, if you don't know, no big deal. Just start at the highest setting and click your way down until you get a solid reading. Honestly, both work just fine.
Okay, now we're ready for the good stuff. We're going to focus on the 3 big measurements that will let you solve, I'd say, about 90% of most electrical problems. That's voltage, resistance, and current. Let's kick things off with voltage.
So first up is voltage, which we measure in volts. By far the easiest way to wrap your head around voltage is to think of it as electrical pressure. It's just like water pressure in a garden hose. Voltage is the force that's pushing all that electricity through the wires. If you have no pressure, you get no flow.
And measuring it is a piece of cake. You plug the black lead into COM, that's your common ground, and the red lead into the V port. Pick the type of voltage you need, AC or DC. Then you just touch the probes across whatever you're testing. The key word here is parallel. You're basically checking the pressure difference between 2 points.
Next on our list is resistance, measured in ohms. Let's stick with our water analogy. If voltage is the pressure pushing the water, resistance is anything that blocks or restricts that flow. Like a really narrow section of pipe. It's going to have high resistance, letting less water through. To measure resistance, you'll use the COM and the omega ports. But listen up, because this is the most important rule, and it is non-negotiable. You absolutely must turn off all the power to the circuit first. If you try to measure resistance on a live circuit, you could get a bogus reading or even wreck your meter. So, power off, then measure across the component.
And finally, we have current, which we measure in amps. This is the actual flow rate of the electricity. It's how much water is actually moving through that pipe every second. So voltage pushes, resistance restricts, and current is what you get as a result.
So all that theory is great, but what's the point if you can't use it, right? Let's put these new skills to work and solve a couple of the most common electrical head scratchers you're likely to run into.
Ah, a classic. Your TV remote dies. You go digging through that one drawer, you know the one, and you find a loose battery. But is it any good, or is it totally dead? Your multimeter knows the answer.
This is a super simple voltage test. Just set your meter to DC volts. Touch the red probe to the little plus side and the black probe to the flat minus side. Here's a pro tip. A brand new 1.5 volt battery will actually read a little bit higher, maybe like 1.59 volts. If you see a reading way down at 1.0 volt or less, yeah, that battery's toast. Toss it.
All right, mystery number 2. You've checked the batteries. They're fresh. You plug something in and nothing. Crickets. The problem might be a broken path somewhere. We need to check if we have a complete circuit. And this is where that continuity function is an absolute lifesaver. All continuity means is that there's a complete, unbroken path from point A to point B. Think of it as checking if a bridge is out. A good wire has continuity. A good fuse has continuity. A broken wire or a blown fuse, no continuity.
So again, and I can't say this enough, make sure the power is off. Turn your dial to that continuity symbol and touch your probes to both ends of the wire or the fuse you're testing. And here's the best part, if the path is good, the meter will beep at you. You don't even have to look at the screen. That beep means it's connected, silence means it's broken. It's that easy.
We've learned some incredibly powerful skills today, but none of them are more important than this next topic. Before you even think about touching a circuit, you need to understand how to keep yourself safe.
Let's be crystal clear about this. Electricity is powerful, and it can be incredibly dangerous. It is not something to fool around with. You have to, always, treat it with the respect that it demands.
So here are the golden rules. Whenever you possibly can, de-energize the circuit. Kill the power. If you absolutely have to work on a live circuit, use the old electrician's trick. Keep one hand in your pocket. This helps prevent a current from ever passing across your chest and your heart. Wear your safety gear, and never, ever, ever bypass a fuse with a piece of wire. That fuse is there for a reason. It's designed to protect you.
And just like that, you've done it. You get the fundamentals now. Voltage tells you the pressure, resistance tells you if there's a blockage, and continuity tells you if the path is clear. These aren't just functions on a dial anymore. They are your brand new diagnostic superpowers.
You've officially gone from being intimidated by this tool to being empowered by it. You can now basically see the invisible and speak the language of electricity. So, the only question I have left for you is this: what mystery are you going to solve first?